Welcome everyone to another learning session. Today we are going to learn about Kubernetes. Irrespective of whether you are a developer or a DevOps engineer or an administrator, irrespective of whether you are working with AWS Cloud, Azure Cloud or GCP or even on-premises, all these places have one thing in common today, and that is Kubernetes. Learning Kubernetes, it can really help you find good jobs and even find better opportunities in your current job also. So without wasting time, let us get started. Kubernetes 101. The agenda for today's session: need for container orchestration, history of Kubernetes. The abbreviation K8S makes easy to write Kubernetes because Kubernetes is a bigger word. And if you see the first K and the last S, you have 8 characters between that first K and last S. And that is why people generally shorten it as K8S. We will look into popular Kubernetes certifications. We'll look into popular Kubernetes solutions. We will learn and understand the basic architectural concepts of Kubernetes, including cluster, node, pod, master node, control plane, and namespace. Then we will look into Kubernetes API and Kubernetes Dashboard. Then we'll look into a tool called Kubectl tool, which we will be using a lot in our hands-on exercises all throughout this tech series. Then we will look into Container Runtime Interface or CRI. Then we will look into hands-on Kubernetes with Minikube. So once you learn the theory, you need to put it into practice, and then only everything will be thorough in your mind. And finally, we will learn how to replace container runtime within Kubernetes with another container runtime. We had learned about various container runtimes and container engines and all in our Containers 101 session, right? The prerequisite for today's session is the Containers 101 session. In Containers 101 session, we had looked into traditional IT infra, server virtualization and hypervisors, differences between containers and virtual machines, container core concepts like images, registries, the container runtime, container engine, etc. Many people know about Docker, but we looked into a lot more container solutions than just Docker. We also looked into Open Container Initiative and the need for container orchestration. Today, we are going to work with one of the most popular container orchestration tools, that is Kubernetes. And we had also briefly discussed about serverless computing, microservices, and few more topics that I felt would be good in your containers and Kubernetes journey. Just in case if you are new to my sessions, I am Hatin Ganigutotu. I've written few books. I've got some awards for those books. I have taken a few certifications. I'm also a Microsoft certified trainer. And you can learn all about me by going to hatin.github.io. So need for container orchestration. We had seen this in Containers 101. A quick recap. It is always good to have someone manage and orchestrate containers. And that is where container orchestration comes. And important container orchestration tasks include high availability, scalability, storage orchestration, automated rollouts and rollbacks, service discovery and role balancing, self-healing, and batch execution. In this tech series, we will learn how Kubernetes can help in this. History of Kubernetes. Kubernetes originally started as an evolution of the large-scale cluster management solution called Borg in Google. I've included a reference link here. Google introduced Kubernetes as an open source version of Borg in 2014. In 2015, Kubernetes version 1.0 got released, and Google partnered with the Linux Foundation to form the Cloud Native Computing Foundation. Currently, CNCF is part of the Linux Foundation and provides support, oversight, and direction for fast-growing cloud-native projects, including Kubernetes, Envoy, Prometheus, and many more. Just in case if you are planning to take a certification, Kubernetes has few certifications: Certified Kubernetes Application Developer CKAD, Certified Kubernetes Administrator CKA, Certified Kubernetes Security Specialist CKS. Popular Kubernetes solutions include Red Hat OpenShift Container Platform, Ranger Enterprise Kubernetes Management, Azure Kubernetes Service on Azure, Elastic Kubernetes Service on AWS, Google Kubernetes Engine on GCP. There are also versions of Kubernetes solutions that you can install in your local as a single node cluster. Assignment number 1 find more Kubernetes solutions than discussed here, just search in Google and find out if we can see more Kubernetes solutions and then share it in our study group. Kubernetes core components and tools, node, cluster, pod, master node and control plane, namespaces, Kubernetes API and Kubernetes Dashboard, the kubectl tool. There are many more components like deployments and a lot more that we'll be discussing in our future sessions. Node and cluster. Nodes are physical or virtual worker machines on which containers are launched by Kubernetes. So basically, Kubernetes is a container orchestration tool. So it has to launch containers somewhere, right? On some machine. That machine could be a physical machine or it could be a virtual machine. A cluster is a set of worker machines and master nodes. A worker node is a node where containerized applications run, and master node is a node where the control plane run. There are a lot of technical terms that are present in today's session. When we do more and more hands-on practical examples, many of these things will become very clear for you. Pod. The worker nodes in Kubernetes does not host containers directly inside them, but they do it in a component called as pod. So you have worker nodes, and within those worker nodes, you don't directly launch your containers, but you launch your containers within a component called as pod. A pod can contain one or more containers, and all these containers within a pod will share the storage volumes, network resources, and a specification for how to run these containers. To scale our application, we add more pods and not more containers. A pod is actually the smallest object that we can create in Kubernetes. Even though a pod can have multiple containers, a pod generally have only one container. A multi-container pod is definitely possible, but that is an exception. Example, a supporting container for a container that need to share the same storage and networking with that container. In such a case, scaling will also happen for both of these containers together. Each pod will have their own IP addresses, even if they are allocated to the same nodes in a cluster by the deployment. Deployments are logical components used to manage the pods in a cluster. So basically, when you look into enterprise applications, you will have much more functionality than just launching a container and then running that container, right? So we'll need things such as rollouts, rollbacks, replication, and a lot of things. Master node and control plane. A master node is a node in a cluster that runs the Kubernetes control plane, and a control plane manages the worker nodes in that cluster. The control plane is responsible for detecting and responding to cluster events. For example, starting up a new pod when a deployment's replicas field is unsatisfied means, imagine that your deployment is managing a cluster with 4 pods. And if one of the pod has gone down, then if you have set up things properly, another pod will automatically come and take its position. So if you say that, okay, we need 4 pods always, then Kubernetes will make sure that we have 4 pods always. And if any goes down, or even if we delete it, Kubernetes has mechanisms to bring another pod and then replace that failed pod or deleted pod. The control plane's components make global decisions about the cluster, such as scheduling. There should be minimum 1 master node, but there can be more for redundancy. Control plane components can actually be run on any machine in the cluster. However, in general, setup scripts start all control plane components on the same machine, and that is called as our master node, and do not run user containers on this machine. Components of a control plane. API server. Kube API server exposes the Kubernetes API. The API server is the front end for Kubernetes control plane, and we communicate with the control plane through this API server. Even though you will not be needing to understand all these components initially, It is always better to have these terms in your mind so that when you see these things in logs or other places, you won't be confused. etcd, which is a distributed and highly available key value store used for storing all cluster data, including workers and masters, and even logs to prevent conflicts between the master nodes. Kubescheduler. Kubescheduler distributes work across nodes by watching for newly created pods with no assigned node and selecting a node from them to run. Kubecontroller manager runs controller processes such as node controller, job controller, endpoints controller, and is responsible for bringing up containers if one fail. We also have a cloud controller manager that runs the controllers that are specific to cloud provider and is not present for on-premises deployments. So there are 5 components primarily for the control plane: API server or Kube API server, etcd, which is a distributed and high available key value store, Kubescheduler, Kubecontroller manager, and cloud controller manager. The Kubernetes API. The Kubernetes API is actually a collection of APIs to define resources that can be used within Kubernetes. The APIs are RESTful, and hence you can use a tool such as curl to connect to them as long as appropriate certificates are used. You can connect to the APIs through the kube proxy component with the kubectl proxy command to avoid configuring certificates needed with the direct API calls. Components of a worker node. We saw the components of a master node or the components of a control plane, right? The components of a worker node include the kubelet, which is the primary node agent that runs on each node. It can register node with the API server from the control plane. The container runtime is also part of the worker node and is needed to run the pods. The Kubernetes network proxy, kube proxy, is the third component. It reflects services as defined in the Kubernetes API on each of these worker nodes and can be used for simple TCP, UDP, and SCTP stream forwarding, or round-robin TCP, UDP, and SCTP forwarding across a set of backends. To understand TCP, UDP, and other networking terms, I would suggest you watch Systems Design Tech Series. TCP and UDP are pretty popular. SCTP stands for Stream Control Transmission Protocol. SCTP is message-oriented, unlike TCP, which is byte-oriented. So we'll discuss more in our systems design discussions. Namespaces. Namespaces provide isolated environments in Kubernetes and useful with multiple projects or teams. Kube system is the namespace for objects created by Kubernetes system and is created by default. It contains ports like kubedns, kubeproxy, Kubernetes Dashboard, etc. Default is a namespace that is created out of the box by most Kubernetes distributions so that we can start creating pods without creating namespaces. Kubens is a tool to switch between Kubernetes and namespaces easily. The kubectl tool, one of the tools that we will be using very frequently. Kubectl is a command line tool for communicating with Kubernetes clusters control plane using the Kubernetes API behind the scenes. The syntax is kubectl command type name flags. The command part, we specify the operation that you want to perform. Example, create, get, describe, delete, etc. In the type part, we specify the resource type. And here it could be pod or pods or nodes. There are different variations that are supported. The more and more you work with Kubernetes from a command line, and that is how most of the people work with Kubernetes, these things will become more and more familiar. And then the name specifies the name of the resource. Example, kubectl get pod 1. Flags specify optional flags. Example, -s or -server. And for help, just run kubectl help. So some useful kubectl commands for cluster nodes, pods, namespaces, and API that can help you get started. The more and more we learn Kubernetes, the more and more we work hands-on with Kubernetes, we'll be learning and getting familiar with a lot of other commands also. Kubectl run command is used to deploy an application on the cluster. Kubectl cluster info command is used to view information about the cluster. Kubectl get nodes command is used to view all nodes in a cluster. Kubectl get namespaces command is used to view all namespaces in a cluster. Kubectl get pods command is used to view all pods in a namespace. By default, it will return the default namespace if we do not provide any namespace. Kubectl delete pod command is used to delete a pod. Kubectl describe resource name. For example, kubectl describe pod nginx. Here, nginx is the name of that pod. It shows details of a specific resource or a group of resource, joining many API calls together to form a detailed description of a given resource or a group of resources. Kubectl API resources return a list of resources defined in the API as per documentation. Kubectl API versions return resource versions as per documentation. And a kubectl explain resource. For example, kubectl explain pod return current version and details including attributes of Kubernetes resources defined in the API as per documentation. So in the hands-on lab, please try to experiment with all of these. Assignment number 2, find out objects that you may find in the kube system namespace using the kubectl tool. We discussed this in the hands-on lab. Do it on your own and share the screenshot in our study group. Kubernetes Dashboard or UI. It is a web interface to manage resources in a Kubernetes cluster. And we can use a dashboard to get familiar with Kubernetes, and is installed by default with Minikube, which is the Kubernetes solution that we'll be using for our labs. It is not recommended in core Kubernetes and may be lagging behind on features available in the core. That is why many people generally prefer working with command line, because command line directly work with the APIs. Changes in UI generally for most of the products happen a bit late. Cloud distributions may have their own web interfaces similar to Kubernetes Dashboard. Container Runtime Interface or CRI. The Kubernetes Container Runtime Interface is a plugin interface that enables kubelet to use different container runtimes without recompiling the cluster components. In our lab, we will be using Docker first, and we will replace it with other container runtimes. The CRI defines the main gRPC protocol for communication between the kubelet and container runtime. Note that gRPC is a technology based on a remote procedure call and uses HTTP 2 under the covers without exposing HTTP to the client or the server. All these core protocols that are related to systems design will be discussed as part of our systems design discussions. And these are some of the ways in which you can set up Kubernetes or practice online. Minikube. Minikube is a lightweight Kubernetes developed by a Kubernetes project itself for making it easy to learn and develop for Kubernetes. We are going to use Minikube for our hands-on exercises for practice. K8S. K8S is a lightweight Kubernetes distribution developed by Ranger, designed to be full-fledged production-ready Kubernetes that is also lightweight. K8S. K8S is a lightweight Kubernetes distribution developed by Canonical and is designed for lightweight production environments. KubeADM. KubeADM is designed to build a production-ready and multi-node but minimalistic Kubernetes cluster that conforms to best practices. We also have hosted solutions on platforms such as AWS, Azure, GCP, etc. So if you are learning one of these clouds, then you can learn Kubernetes along with those solutions. Hands-on with Kubernetes using Minikube. Theoretical sessions, I take it in a way that it will be okay to even listen, even if you are not watching it properly, so that you can listen it while you are doing something else also. Maybe doing gardening or maybe cleaning your house, and then you can get familiar with all of these terms and names and concepts and all. But hands-on, you'll definitely have to do it hands-on. There is no shortcut to success, or there is no shortcut to hands-on. So there is a question, how many worker nodes can we set up? It depends on your availability requirements and cost you are willing to incur. As we will see, we can even set up everything in a single machine. Your master node, worker node, all the control plane components, all worker node components, everything in a single machine. And that is what you are going to do for your lab. The exact limit I need to check. How many of you are using a Windows machine for your learning and practice? And how many of you are using a Linux machine? Finally, how many of you are using a Mac? And when it comes to Mac, are you using the traditional Intel chip or the recent M1 and M2? So I have systems running on traditional Mac with Intel chipsets as well as the M2. As of now, M1 M2 has a little bit of limitations with respect to some of the practice labs. So you may have to do it on a different machine, or you may have to do it on a virtual machine on your local machine. Whoever has attended the Containers 101 session, tell me if you want to run a virtual machine on your laptop, which is already running on some operating system, what kind of hypervisor will you use? Will you use a type 1 hypervisor or type 2 hypervisor? Type 2, right? So whatever we are learning in a session, you may not have a hands-on immediately in that session, but in the next session or upcoming sessions, as part of exploring other things, we may get hands-on for them. So today we'll be exploring some of the type 2 hypervisors also. A quick note about Minikube. Minikube is a local Kubernetes focusing on making it easy to learn and develop for Kubernetes. Minikube has a single node cluster, and all the control plane and worker node components are present in this single node. You need a Docker or similarly compatible container or a VM environment such as HyperKit, Hyper-V, KVM, Parallel, Spotman, VirtualBox, VMware Fusion, or Workspace. It has a very low systems requirement to run, so you can run even from your laptop. 2 GB RAM is minimum, but 8 GB is recommended. 20 GB is minimum for disk space, but 40 GB is good to have or recommended. You can refer to minikube.6.k8s.io/docs/start for getting started with Minikube. For this particular hands-on lab, you will need to install this software on your local laptop or wherever you are planning to do this lab. First of all, Minikube. And for Minikube, you need to have one of the following: VirtualBox, VMware, Docker, Hyper-V, or Parallels. You can use VirtualBox in Windows or Linux or Mac, or VMware Fusion for Mac, or Hyper-V for supported Windows operating systems. So for Home Edition, I'm not sure Hyper-V is supported, but for most of the other editions, Hyper-V is supported. It comes by default. You may have to just enable it. But if you want consistency across all platforms, you can use VirtualBox, which will work in almost all of the environments, including Windows, Linux, Mac, etc. And for Apple Macs, VMware Fusion may also be a good choice. For personal use, it is also free. You can check doc for all supported Minikube drivers. There could be more added later also. Just search for Minikube drivers and you can go to the Minikube drivers page and see what all drivers are available and pick one that you are comfortable with or you want to experiment with. Mac and Linux users can use Homebrew. Homebrew is a package manager software. So if you install Homebrew, you can just ask Brew to install other software. Only thing you will have to install will be Homebrew, and then Brew will install other software. You can just say Brew install Minikube, and magically it will be installed, and then you can use these package manager tools for even updating this software. Windows users can use a package manager called as Chocolate package manager. After installing Minikube, you can just run Minikube help to make sure Minikube was installed and also it was added to the path. Even if it is installed, if it is not added to the path, when you say Minikube, it will not be available, right? Sometimes your installation mechanism might automatically add, or it will give you some instructions on how to add, or maybe you will have to add to the path on your own. But in any way, you have to make sure that you can run a Minikube help. And if you are stuck, you can just ask in our study group. Kubectl, even though Kubectl comes inside Minikube, it is good to install Kubectl separately. The Kubectl within Minikube, you will have to call Minikube Kubectl, Minikube Kubectl. Why to call Minikube Kubectl always? If you have installed a Kubectl outside of a Minikube also, you can simply call the Kubectl. And once you do that, you can verify with the Kubectl help. And many of these installations are straightforward. And if you are stuck, you can first always Google. If you are again stuck, then you can ask in the study group. Visual Studio Code with the Kubernetes extension is good to have whenever you are working with Kubernetes. In today's session, it may not be needed, but later, whenever we are working with the Kubernetes with YAML, this is really going to help you. So starting Minikube in Mac using the VMware driver. So once you have installed and set up everything, you can just try running Minikube status. And when you run for the first time, you should get a response similar to below. Profile Minikube not found. Run Minikube profile list to view all profiles. To start a cluster, run Minikube start. This is because we have not started the cluster at all. You can run Minikube start and then provide the driver name. Driver name could be VMware, or driver name could be VirtualBox, or it could be Hyper-V. Depending on what driver you are planning to use, the driver should have been already present and enabled in your machine. So this is a link where you can find all the available drivers, and then you can replace the driver name as needed. So now run Minikube status. So now you should get a response like type control plane, host running, kubelet running, API server running, kubeconfig configured. So if you see a similar response, then everything is good and fine. So result of running start driver equal to VMware. So Minikube version on Darwin 13.1 using the VMware driver based on user configuration. Downloading VM boot image, starting control plane node Minikube in cluster Minikube. Downloading Kubernetes version 1.25.3. Creating a VMware VM, preparing Kubernetes, generating certificates and keys, booting up control plane, configuring RBAC rules, verifying Kubernetes components, using image gcr.io/K8S Minikube /storage provisioner v5, enabled add-ons, storage provisioner, default storage class, etc. etc. You can go through this, and also default namespace is enabled by default. So you can explore these things. The more you explore, you will become more and more familiar with Kubernetes terms. And as I mentioned before, on my Mac with M2 chipset, I could not successfully enable and run Minikube. Looks like Minikube doesn't provide support for Apple chips M1 or M2. It could change by the time you watch this recording. So feel free to search online or try it out once. And if you are able to successfully do it, please provide an update under this recording when it is uploaded to YouTube, or better share it in our study group so that others can also experiment and then get right results. If you want to start Minikube on Windows with VirtualBox, you can start Minikube by running Minikube start driver equal to VirtualBox. Note we can use Chocolatey package manager to install Minikube in Windows by running choco install Minikube. So you should have already a Chocolatey, and then you can install a choco install Minikube. Once you have set up a cluster, try running a Minikube IP. It should give the private IP of our Minikube VM. You can try connecting to this Minikube VM. A Kubernetes solution such as Minikube will have a container runtime inside, and it could be a Docker or something else also. So Docker is the default one here. you can connect to Docker over SSH as a SSH Docker at whatever IP you get from Minikube IP. And it will ask for fingerprint confirmation, type yes. And if it asks for password, type TC user. Username is Docker and TC user is the default password. In case if it changes over time, I will try to update it below the video. After login, type Docker PS. You should see containers with names like K8S storage provisioner, K8S core DNS, K8S port core DNS, K8S queue proxy, K8S port queue proxy, K8S port storage provisioner, K8S kube scheduler, K8S etc, K8S kube API server, K8S kube controller manager, K8S port etcd, K8S port kube scheduler, K8S port kube controller manager, K8S port kube API server Minikube. Once you explore whatever is running with Docker PS, you can exit by just typing exit. You can explore the cluster. You can run kubectl cluster info. And this will give information such as Kubernetes control plane is running at this IP with this port. Core DNS is running at this IP with this port. And you can run kubectl get nodes. And by default, you'll get only one node because it's a single node cluster, right? And then you can try running kubectl get namespaces. We learned about namespaces, right? So if you run now, you should get at least these namespaces like default, which is created by default for hosting your pods, kube node lease, kube public, kube system, etc. If you try kubectl get pods, by default, it will check for pods within the default namespace. You should get a message, no resources found in default namespace because we have not created anything in the default namespace. Then you can run kubectl get pods namespace equal to kube system. This will return all pods that are available within the kube system namespace. This includes core DNS, etcd, kube API server Minikube, kube controller manager Minikube, kube proxy, kube scheduler Minikube, storage provisioner. When you do this lab as a exercise, execute above command for other namespaces and list the pods under them if they are available, and share results in our study group. Exploring the cluster, run kubectl run nginx image equal to nginx. So here you are running kubectl by providing an image. So basically you will be running a container, and that is why we use a container orchestration tool, right? To run a container. And to run a container, what do we need? We need a container image. So we learned in Containers 101, right? What container images are, what containers are, what container registries are. So here, when you run a kubectl run nginx -- image equal to nginx, it will say pod /nginx created. But did we provide this image? Where did the container pull this image? If you have attended Containers 101, tell me. We did not provide any image here. We just told kubectl run nginx -- image equal to nginx. Where did Kubernetes get that image from? Okay, registry. Which registry? Okay, it will be Docker Hub registry because we are using Docker here, right? That is the default registry. And to find out more of this image, you can just Google for Docker nginx, and then you should be able to get to the page where the details of official Docker image is present. So after a few minutes, you can run kubectl get pods. So now your default namespace will have a pod called nginx, and its status is now running. You can see the age, basically for how much time it has been running. So after that, you can run a kubectl describe pod nginx to get more information about this particular new nginx pod that was created. The response of a kubectl describe pod nginx command will include details such as name, which is nginx here, namespace, which is default here, priority, service account, node, start time, labels, annotations, status, IP, containers, conditions, volumes, QoS class, node selectors, tolerations, and even events. A lot of information is present in the response. You can explore them. You may not understand all of them now, but at least you will get familiar with all of them, so that when we actually learn many of these things in detail, that will really help. We can continue to explore the cluster. And finally, you can clean up by deleting the pod, run kubectl delete pod nginx. And after that, if you run kubectl get pods, you should not see any pods in the default namespace. Until now, we explored Kubernetes using Docker as the runtime. So now, let us see how we can change Docker to something else. Before changing, you'll have to do 2 steps. First, you have to stop Minikube, and then you'll have to delete the current configuration. Before changing the container runtime, example from Docker to CRI or Docker to containerd, etc., or for even changing the driver from VMware to VirtualBox, we need to stop and delete Minikube. It is very simple. Simply type a Minikube stop. Once it is stopped, you can type Minikube delete. Now start a Minikube specifying the new runtime. Minikube start driver equal to VMware or VirtualBox or whatever you want to use. And container runtime equal to CRIO. We could also use containerd here. So Minikube start minus minus driver equal to VMware minus minus container runtime equal to CRIO. By default, it was Docker, but we can specify a different container runtime instead here. We have learned about container runtimes and all in Kubernetes101, right? And maybe you can experiment with some of those that are not listed here, and then just share updates in our study group about what you experimented and what was the result. Once you start with a different container runtime than Docker, you can find the Minikube IP like before by running Minikube IP, and try to log in like before, like SSH Docker at IP using the password as TC user. You can now run Docker PS like the same way you did before, but now you will not find anything. It will say cannot connect to the Docker daemon at this URL because we are not using Docker container runtime. Instead, try running sudo CRI CTL PS, and you should see names such as storage provisioner, core DNS, kube proxy, kube scheduler, kube API server, kube controller manager, etcd, etc. And if you face any issues with respect to bad SSH, you may delete existing fingerprint and then add again as part of the SSH step. And assignment 3 will be changing the container runtime in the hands-on lab to containerd instead of CRI or Docker. So what will you do? You will stop Minikube, you will delete Minikube, and then you will start with whatever driver you want to use, VMware or VirtualBox or Hyper-V or whatever you want to use, and specifying the container runtime as containerd. So this one, once you do, you share the result in our study group. So we had an introduction to Kubernetes, and we also looked into some of the important terms and concepts and tools that we'll be working on. And finally, we also set up our local machine to work with Kubernetes using Minikube. So do follow the steps and do the exercise. And if you are not able to do, just mention the study group and I'd be more than happy to help you out, or other people who have completed would help you out. And also you need to share your results, at least for the assignments that were given to you in our study group. Let us all learn together and grow together. Bye bye for now, and meet you all in next session.